This is Lesson 11, Rational Expressions. So what exactly are rational expressions? A rational expression is the quotient of two polynomials. Here are two examples of rational expressions, x minus 2 over 4 and x squared plus 1 over x squared plus 2x minus 3. So anytime you have a quotient of two polynomials, you have a rational expression. Now you might remember the term domain. This is the set of real numbers for which an algebraic expression is defined. Now, since a rational expression includes division, basically, it's a numerator divided by the denominator, there are going to be times where the denominator cannot be 0, okay? And therefore, the rational expression will not be defined. Now, looking at our two examples, the first example there, x minus 2 over 4, the denominator is always 4, so therefore there are no values for which this is not defined. However, the second expression, x squared plus 1 over x squared plus 2x minus 3, anytime that denominator is equal to 0, that rational expression is not defined. So let's look at another example. Now here's an example, 4 over x minus 2. So where is x minus 2 equal to 0? Well, x minus 2 is equal to 0 at x equals 2. So therefore, the domain of this rational expression is all real numbers except x equals 2. So in this particular case, x cannot equal 2. So let's look at another example, x over x squared minus 1. Well, where is the denominator x squared minus 1 equal to 0? Well, if we factor x squared minus 1, we get x over x plus 1 times x minus 1. So therefore, the denominator is going to be 0 if x is equal to 1 or minus 1. So therefore, those are the two values that x cannot be. So the domain for this expression is all real numbers except x equals plus 1 and x equals minus 1. Now let's talk about simplifying rational expressions. A rational expression is said to be simplified if the numerator and denominator have no common factors other than plus or minus 1. So let's look at this example. We got x to the third plus x squared over x plus 1. Let's factor the numerator and see if we have any common factors with the denominator. So if we factor the numerator, we get x squared times x plus 1 over x plus 1. But now notice we have x plus 1 and x plus 1 as common factors, so we can cancel these out, and our final answer for simplifying this expression is x squared. Now we're going to talk about multiplying rational fractions. There are 3 steps that you need to follow when multiplying rational fractions. First, factor all numerators and denominators completely. Second, divide numerators and denominators by common factors. And last, multiply the remaining factors in the numerators and multiply the remaining factors in the denominators. So let's look at an example. I've got x minus 7 over x minus 1 times x squared minus 1 over 3x minus 21. Now remember, the first step is to factor all numerators and denominators completely. Okay, now that we've factored the numerators and denominators completely, step 2 is to divide numerators and denominators by common factors. Well, I can see there's an x minus 1 here, and an x minus 1 there, and an x minus 7 here, and an x minus 7 there. Okay? Well, now we need to multiply the remaining factors in the numerators and multiply the remaining factors in the denominators. Well, we were able to cancel out a lot, so there's not really a whole lot left. So our final answer is going to be simply x plus 1 over 3. Now, an important thing to remember in this type of a problem, though, is that even though we have multiplied this out and come up with a simplified answer, we still have values that x cannot be. For example, x cannot equal minus 1. Remember we had, plus 1, because we had x minus 1 here. X also cannot equal plus 7, because we had x minus 7 here. So even though we have simplified this expression, we still have the following restrictions: that x cannot equal plus 1, and similarly x cannot equal 7. Now let's talk about dividing rational expressions. So let's start by talking about a simple fraction, division of fractions. Say I've got 1/2 divided by 1/3. As you recall, whenever you're dividing fractions, you take the second fraction and flip it, or basically multiply by the inverse. So this simply becomes 1/2 times 3/1, or 3/2. Well, the same rules apply if we're talking rational expressions. So let's look at an example. Let's say I've got x squared minus 2x minus 8 over x squared minus 9. And I'm dividing that by x minus 4 over x plus 3. So, just like we did when we had basic fractions, I'm going to take that second term, the x minus 4 over x plus 3, flip it, and change the problem from being a division problem to being a multiplication problem. We now have x squared minus 2x minus 8 over x squared minus 9 times x plus 3 over x minus 4. Now, since this is a multiplication problem, we simply follow the rules for multiplication by factoring, canceling, and multiplying. Alright, now that we've factored, we can take and cancel out any common factors we have. So I see an x minus 4 here, an x minus 4 there, an x plus 3 here, and an x plus 3 there. And what we're left with, so our final result is simply x plus 2 over x minus. But again, note, there are values that this rational expression cannot be, because if you go back up to the factored terms here, we can see that x cannot equal plus 3, x cannot equal minus 3, and x cannot equal plus 4. So there's 3 values that x cannot have, even though this is a simplified solution to this division problem. So what about adding and subtracting rational expressions? Well, first of all, just like adding and subtracting fractions, if the denominators are the same, it's pretty straightforward. Again, if these were simple fractions, and say I had 1/5 plus 2/5, the denominators are the same, so we simply add the numerators and it becomes 3/5. Now if I had rational expressions instead, for example, x over x plus 1 plus 3x plus 2 over x plus 1, you can see that we have the same denominator, so all we have to do is add the numerators. So our result would simply be 4x plus 2 over x plus 1. So now let's look at adding and subtracting when our rational expressions have different denominators. So again, let's start by looking at how we handled basic fractions. Say I had 1/2 plus 1/3. I would have to come up with a common denominator before I could take and add those. So in this case, our common denominator is going to be 6. So the 1/2 you multiply by 3 over 3, and the 1/3 you multiply by 2 over 2. So now our addition problem becomes 3/6 plus 2/6. So there it is, adding two fractions with different denominators. Well, let's see how it works when you've got two rational expressions with different denominators. So let's look at this example. 3 over x plus 1 plus 5 over x minus 1. Obviously, we don't have the same denominators, so we have to create the same denominator. So now we simply take the first expression and multiply it by x minus 1 over x minus 1, and the second expression and multiply it by x plus 1 over x plus 1, to give us a common denominator of x plus 1 times x minus 1. So now we can combine the numerators and come up with our final answer. And that answer is 8x plus 2 over x plus 1 times x minus 1. Now one last thing we need to talk about with regards to rational expressions is complex rational expressions. Complex rational expressions are simply ones that have numerators or denominators containing one or more rational expressions. For example, this is a complex rational expression. Notice we have a rational expression in both the numerator and the denominator. Now, when you have this, you're going to basically want to simplify it. And you're going to follow the rules that we already talked about in terms of adding and subtracting rational expressions for the numerator and for the denominator, and then dividing the numerator by the denominator. And it's going to look something like this. So our final result is simply x plus 1 over x minus 1. So basically you can use the rules you learned for rational expressions when it comes to complex rational expressions. It's just that there's a lot more steps involved. Now this concludes this particular lesson. So again, try your hand at the worksheet, and once you feel comfortable with that, move on to the mastery quiz. If you have any questions or need help with anything, make sure you use the discussion port. Thank you.